Hi guys, welcome back. Today we're going to be looking at circle functions, where the circle function actually comes from, and how we can use transformations of the circle function to sketch functions. So let's go ahead and let's have a look here at where the circle function is actually derived from. So looking at my circle here, I can see the radius of my circle, so this point here from the center to the edge, is equal to this black line along here. So how do I go ahead and how do I find the length of this radius? Well, since I've got this triangle here, I can actually use Pythagoras' theorem to help me to find this. So what I need is I need the length of this line along here. So for this particular point, we're given the point x, y. So this length along here is going to be equivalent to this x coordinate. This y point, this y coordinate, is going to be equivalent to the length of this green line here. So we would find this value of r using Pythagoras' theorem, and we would write r squared is equal to x squared plus y squared. So this is the basic form of a circle. So let's go ahead and have a look at some of the features of this circle. So all I've done is I've just put this into Desmos and I've just let the radius equal to 1. So this is a unit circle. And what I want to look at is I want to look at the edges of my circle, I want to look at the radius of my circle, and I want to look at the center of my circle. So just looking at the center of this circle here, I can see that the center of this circle is going to be at the origin, 0, 0. If I was to look at the edges of this circle, there would be an edge here at 1, 0, an edge at negative 1, 0, another edge at 0, 1, and another edge at 0, negative 1. And this is because this is a unit circle with a radius of the length 1. So if I was to try to find the length of the radius at any single angle or any single point of this circle, it's going to be equal to 1. So what happens if we were to change the length of the radius? So this is now a circle with the length of radius 4. If you're not sure where I'm getting this from, I've got a slider along here and I've just changed the value of this slider so that the radius is equal to 4. So what do we know about the center of our circle? Well, the center of our circle is still at 0, 0. It's still at the origin. What about the edges of our circle? Well, we've got an edge here at 4, 0. We've got another edge here at negative 4, 0. We've got another edge here at 0, 4, and then we've got a final edge here at 0, negative 4. Now with our actual function, keeping in mind that the function over on this side here, this is actually r squared. And so if we were to say that this value here was equal to 4, that would mean that the equation would actually be equal to 16. And so when we have an equation that's equal to x squared plus y squared is equal to 16, that length of that radius is going to be the square root of that value. So that's where we get the information about the edges. So what would we expect to see from something that had a value of x squared plus y squared is equal to 9? Now remembering that this value here is equivalent to the radius squared. So in this case, the length of my radius is now only going to be 3. Let's have a look at the center. So the center, still at the origin, still at 0, 0. And the edges now, well, the edges should now have changed to reflect that the radius is equal to 3. So we've got one edge at 3, 0, one edge at negative 3, 0, one edge at 0, 3, and one edge at 0, negative 3. So we can use this information to help us sketch a circle. So let's go through and do an example. Sketch the circle 4x squared plus 4y squared is equal to 25. Now, unlike our previous examples, this has this value of 4 out the front of my x squared and my y squared. So what I'm going to do is I'm going to divide the whole thing through by 4 so that I have x squared plus y squared is equal to 25 over 4. Now, remember, this is equal to the radius squared. So the value of the radius is actually going to be equal to the square root of 25 over 4, which is going to be equal to 5 over 2, or 2.5. So the length of our radius is now going to be 2.5. As before, the center of this circle is going to be at the origin, and we should have edges at 2.50, negative 2.50, one at 0, 2.5, and one at negative 0, negative 2.5. So let's go ahead and sketch this circle. So for this circle, I've labeled each of my edges, and I'm also going to go ahead and I'm going to label the center in the middle here. I also know that the length of my radius around the circle is going to be equal to 2.5 going the whole way around. So let's go ahead and let's check this solution in Desmos. Okay, so remember in the formula, value is equivalent to r squared, and we can see here we've got one edge at 2.5, one edge at negative 2.5, one edge here at y equals to 2.5, and then y equals to negative 2.5. So this is what the circle looks like, and again, we can see that this radius is going to be equal to 2.5. Let's go ahead now and let's start talking about some different transformations. So some horizontal transformations of the circle and some vertical transformation or translations of the circle. So here we have our general circle. So what I've done is I've altered the formula ever so slightly to include some transformation values or some translation values. So here we've got x plus h squared rather than just having x squared, because this is going to move my axis or move my circle in the horizontal direction. I've got here y plus k squared, and this k is going to move my circle in the vertical direction. And of course, I've still got my value here for r squared. So if I was to increase this value for r, that's going to increase the size of my circle. And again, remembering that this value here is the length of the radius, and when we pop it in the formula, it's got to be the squared version. Okay, so let's see what happens now when we start to transform this. So as h becomes positive, which way or which direction do we think this is going to move in? As we've seen with transformations previously, the horizontal axis always seems to do the opposite of what we think. So I'm thinking that if I was to have a positive value of h, that this is going to move into the left direction. So let's see if this is the case. And indeed it is the case. And so as we become smaller and more negative, it's going to move to the right-hand side. So we can see that just like in previous examples where we've done horizontal and vertical transformations, the horizontal is the opposite way to what we think. So when we have positive values for h, that's going to move the circle to the left. And when we have negative values for h, that's going to move the circle towards the right again. Okay, so let's have a look then at the vertical translation. Now this is a circle, and so what's happening with this is this whole area or this whole part of this equation is being squared. So I'm actually thinking, just like we saw in the horizontal example, this might actually be the opposite to what we think as well. Because normally when we're dealing with functions, we just have something is equal to y, right? Don't we? But here, y is actually an essential part of this equation. So let's see what happens as we increase this value of k. So because we've now squared this, right? So if I was to substitute in a negative value here for k, a positive value for k, that's actually going to shift the circle downwards. It's the opposite to what we think. And the reason for that in this case is because of that squared that we've done or applied to this y function. So that must mean that as k becomes more negative, that it's actually going to shift upwards. So circle functions are kind of unique in this sense because we don't see this transformation with any of the other graphs that we've dealt with in the past. So that's really cool. That's a really unique feature of circles. So what happens then to the radius when we do this? Nothing. It stays the same. When we manipulate these values of h and k, we still have the exact same circle. It's just been moved across the page. So how would we then find the new center of the circle, seeing as we already know what the radius is going to be? Let's change these values. I've just manipulated the x-axis or the x translation so that we can see when h is equal to 5, so when it's a positive, it's going to move to the left by 5 units. And so the new center of our circle, rather than being at the origin 0, 0, is going to be negative 5, 0. So where is the new center of the circle going to be if I manipulate the k value? So as we can see, I've changed this value here to negative 2, and because this is being squared now, this is changing it so that it's the opposite of what we think. So when this is negative, we're going to now shift our circle upwards by 2 units. So since this is shifted upwards, our x-coordinate, remember, was at negative 5, and now it's been shifted up 2. So the new center of our circle is going to be at negative 5, 2. So let's go ahead and pop this in our notes section. So since both of these values are the opposite to what we think, I've actually changed both of them to x minus h and then y minus k, because it's doing the opposite of what we expect it's going to do. And so when we translate by h units, remember this negative means it's moving to the right, and this negative here is moving this upwards. So that means that our new circle, or the center of our circle, is going to be at positive h, positive k, and that's going to be equal to r squared. So let's have a go at a question. So since this is in this form here where I've got x minus a number, I know that this means it's going to shift to the right by 4 units, and so the center has moved 4. And for this one here, this means it's shifted to the top by 2 units, so the new center is going to be at positive 4, positive 2. So quick little way to remember the circle function is the opposite of what we think. So that's going to be our center. How do we now find the radius of our circle? Well, remembering from our previous function, this r squared value at the end here is equal to 36, and so the square root of 36 is equal to 6. So the length of our radius is 6. The last thing that we need to do is we need to find our edges. Now previously these would have just been from the origin, we would have added 6 or taken away 6 in the x and the y axis, but this time what we're going to do is we're going to do that from the center. So to find the horizontal edges, this is going to be 4 plus 6. So we're going to have one at 10, and I'm not sure what the y coordinate is of that just yet. And then I'm also going to have one at 4 minus 6. So that's 6 units away from the center. That's how long the radius is. And that will be at negative 2. And then again, I don't know what that y coordinate is just yet. Okay, so let's find then our y coordinate. Actually, we do know what this is because this has been shifted up 2 units. So we can actually change these to 10, 2 and negative 2, 2. So that's for our x edges. So let's go ahead and do the same thing now for our y edges. So because the center has been shifted up 4, that's going to be the x coordinate for both of our edges for y. And then we're going to add 6 to 2. So 2 plus 6 is going to give me 8. So that's shifted my top edge up to 4, 8. And then if I wanted to find my bottom edge, that's going to be 2 minus 6, which is going to be negative 4. And so my new bottom y edge is going to be at 4, negative 4. Let's pop this in Desmos. Let's double check our solution. So here we have our center at 4, 2, just like we predicted from our formula. And then we should have a radius length equal to 6. And we can see here that this is indeed 6 units long. We should have this edge here at 10, 2, which we do. The other edge was at negative 2, 2. For our y edges, we had one at 4, 8, and we had one at 4 and negative 4. So we have sketched this circle correctly. So let's go ahead and let's summarize some tips and tricks from today's lesson. So here's the summary of all of the key information that we've learnt for today. So if there's one thing that you take away from this video, this should be it. So a graph of the form x minus h squared plus y take k squared is equal to our radius squared. If we want to find the center, so remembering when this is negative, this is going to have a positive center. So our center will be at positive h, positive k. This radius here, when it's given in the formula, is always in the squared form. When we find it, we have to find the square root of this value to get the length of our radius. If we were to find the edges, we would go from the center and we would add, well, in this case, we added 6 because that was the length of our radius. So we would add the length of our radius to find our x edges and subtract to find our other x edge, and same thing with the y edges. And that's how we find all of the key details for the center of our circle. Now, some other key information that we might see as well, but it's not necessary for you to actually calculate this or actually sketch this on the graph, would be our x-intercepts and our y-intercepts that we see here. So that's how we find equations from a circle, and that's how we draw circles using the transformations. Bye guys, I'll see you in the next one.